All right, this is the Algebra 1A Unit 2 Lesson 9 project help. This project is about a shoplifter, and more specifically, the standard form equation of a line. Here we go. According to the National Retail Federation, U.S. retailers lost $32 billion due to shoplifting and theft in 2015. All right, so the scenario is this. A shoplifter is 32 meters from the store when security is informed. According to video surveillance, the shoplifter left the mall 24 seconds ago. The speed of the shoplifter is unknown, but the shoplifter's movements can be represented by a line. If X represents time in relation to when security was informed of the crime, and Y represents the distance the shoplifter is from the store, what are the X-intercepts and what are the Y-intercepts? All right, so one of the key pieces of information in this problem is the fact that time represents when security was informed. Right? It's in relation to when they were informed. So we know that the shoplifter left the mall 24 seconds before security was informed of the crime. So if X is talking about time in relation to when security was informed, then that would be minus 24 seconds. All right, so what we're writing the coordinates for, what we're end up graphing here, is we're going to have time on our x-axis, right? So time is our x variable. Right? That's what they tell us there, that's time. And then notice they say that y represents the distance. So we're going to have time and distance, just like you did in the other previous lessons for this project. All right, so what's the time? What's at the initial time when security found out that the crime happened? It would have been negative 24 seconds, because it was 24 seconds ago that security was informed. So at that point, negative 24 seconds ago, that's when the shoplifter would have been 0 meters from the mall, because that's when they first left the mall. All right, so we get our x-intercept at negative 24 and 0. Well, how about the coordinates of the y-intercept then? So the y-intercept, remember, is when x is 0. So in this case, that means at time 0, what was the distance from the mall? Remember, time 0 means when security is informed of the crime. And it says right here that the shoplifter was 32 meters from the store when security is informed. So that's time 0. When security is informed, that's time 0. How far is the shoplifter from the store? Well, in this case, 32 meters. All right, so those are our x and y intercepts. Okay, so question 2 asks, now that we know what the x and y intercepts are, what is the slope-intercept form of the equation of a line that represents that movement? So remember, the slope-intercept form is y equals mx plus b. So in order to figure this out, we need 2 pieces of information. We need to know the slope, and then we need to know the y-intercept. Well, luckily, we already have the y-intercept. We just figured that out in the last problem. All right, so we know that the y-intercept, that's when x is 0, is 32. So we already know that this b here in our equation is 32. So we got half of what we need. All right, so now we need to figure out the slope. We can figure out the slope because we have 2 points, and we can use the slope formula. So you take the points that you had from your previous problem. Let's utilize the slope formula. So we do 32 minus 0. Right, subtracting the x's, the y's. And then we're going to subtract the x's. Right, it's the difference of rise over run. Notice how I write 0 minus a minus 24. All right, so then on top here, we just end up with 32. And on the bottom, we end up with 24 positive, right? The opposite of a negative is a positive. And now I'm going to go ahead and reduce this fraction. In this case, I notice that they both have the least common, or greatest common factor of 8. So I'm going to divide top and bottom by 8. All right, and then when I do that here, I would get 4 thirds. All right, so now we can write our slope-intercept equation. That's what we were asked to do. We know the slope, and we know the y-intercept. So now I can write y is equal to 4 thirds x plus 32. There, we've just written the slope-intercept form of the equation of the line. I encourage you here to pause this video, rewind it, and then answer that same question in the project as you go through the project yourself. All right, so now question 3 asks us to take our equation that we just wrote and let's rearrange it into standard form. All right, so standard form equation of a line, which is what this lesson is about, is represented as ax plus by equals c. So you have your variables with their coefficients on the left side of the equation and some constant on the right side. It's important to note here that a, b, and c must be integers. And in fact, there's a greater restriction on a. It also has to be positive, greater than or equal to 0. All right, so if I'm going to go ahead and start rearranging this equation, I need to get rid of the fractions, right? Because we can't have fractions in our standard form. Right, so one way I can do that is multiply everything through by the denominator of the fraction that we have here. So we have the fraction 4/3 as our coefficient of x. So to get rid of that fraction, I can multiply everything through by 3. So that's my first step. I'm going to multiply the entire slope-intercept equation by the denominator of our fraction here. So now we get that 3y is equal to, here I would have 3 times 4 divided by 3, or the 3's would cancel out. So you're just left with the 4x. And then finally, 3 times 32, in my case here, is 96. All right, so we're almost there, but it doesn't quite look like this yet, right? I need to get my x's and y's together on one side of the equation. All right, so I have a positive 4x here, so I can subtract it from both sides. And then when I do that, I would end up with negative 4x plus 3y is equal to 96. So all I did there was pick up the 4x. It was a positive 4x term, and I changed the sign and pushed it to the other side of the equation. Right now, this looks really close to their form here. There's just one extra thing we have to do. The a term here, in this case, the negative 4, can't be negative. So when they define the general form, they define that that a term has to be positive. So in this case, it's negative right now. So to make it a positive, I can multiply through by negative 1. I can multiply every term by negative 1. All right, to change the signs. And basically multiplying by negative 1 just changes the signs everywhere. So we get that 4x minus 3y is equal to negative 96. So remember what I did here. The step that I did was to multiply through everything by negative 1. All right, so now we have our standard form of the equation of the line. So notice how we converted from, in this case, slope-intercept form to standard form. We could go from this form, or any of these forms, to point-slope form. All right, so in your discussion questions where they're talking about can you get one form to another, of course you can. All right. Question 4 says, how can you tell if your slope-intercept equation and your standard equation actually represent the same line? Okay, so we converted our slope-intercept form into our standard form, and now we're being asked, how can I actually verify that they're the same line? Well, there's a few ways. One, you could always graph them, right? You could pull out a graphing calculator and make sure that they in fact lie on the same line. Another thing you could do is check points to see if 2 or more points are on the same line. Because remember, if you have 2 points define a line. So there's only one line you can draw through 2 points. So if you had the same 2 points and the same 2 equations, then they would have to be the same line. Well, luckily, we already have 2 points that we figured out from question 1. Right? We have the x-intercept and we have the y-intercept. So if I check that the x-intercept is in fact makes a true statement for both equations, and then the y-intercept also makes both equations true, then I can guarantee that they form the same line. All right, so let's go ahead and do that for this. So in this case, I would go ahead and let's plug in the x-intercept into this equation, our slope-intercept. All right, so this is saying the x is negative 24 and the y is what is 0. So does 0 really equal 4/3 times negative 24 over 1 plus 32? Is this a true statement? Let's check it out. All right, so in case here, if I multiply and do some simplification here, this 3 would cancel out and make this negative 24, negative 8. So all I did there was reduce. And then now 4 times negative 8 is negative 32. And negative 32 plus a positive 32 is in fact 0. All right, so we got a true statement there. Now let's go ahead and check that the y-intercept that we generated from our standard equation actually works and gives us a true statement in our slope-intercept form. All right, so we're asking is 32. Remember, this is the y-coordinate. Make sure you don't switch those when you're plugging them in. Is 32 equal to 4/3 times 0 plus 32? All right, well, 0 times anything is 0, so this whole term cancels out. And now we're just left with the statement that 32 equals 32. All right, that is a true statement, which verifies that that point is on that line. All right, so there we just verified that these two equations are in fact the same line.